Hello, friends. Welcome to our live broadcast. I'm Emily. With significant advantage in construction efficiency and quality control, precast box girder has become the preferred structure form for many bridge projects. The construction process involves several complex and crucial technical aspects, each of which directly impact the overall quality and safety of the bridge. Let's explore the key technologies involved in precast box girder construction. First, let me provide an overview of our company. Our company, Shandong Boyoun Heavy Industry Corporation Limited, was founded in 2016 and 6 and focuses on the R&D, fabrication, marketing, on-site technical services of steel formwork for bridge, viaduct, tunnel engineering. The headquarters and main factory are located in Binzhou City of Shandong, China, with international department located in Beijing. The annual output is more than 75,000 tons. Boyoun has been qualified by ISO QM system since its foundation. More than 30% patents have been approved each year. Boyoun has served over 1,200 infrastructure projects, mainly for high-speed rail, expressway, railway, highway, and other large-scale infrastructure projects, with experienced formwork solutions cooperated with giant state-owned enterprises and well-known overseas construction groups. Over the years, we have gained extensive experience and expertise and built a strong reputation in the industry. We are dedicated to providing our customers with high-quality products and, more importantly, with excellent service and technical innovation. Rebar banding and corrugated pipes in installation. Before we pour any concrete or install any formwork, the first and the most critical step is to ensure the accuracy and firmness of the steel structure inside the box girder. Rebar banding and corrugated pipes in installation are the foundation of precast box girder construction. If this step goes wrong, all subsequent processes will be meaningless, and it will directly lead to structure safety hazards such as insufficient bearing capacity and ground leakage in processing in pre-stressing. So let's dive deep into the standard operating procedures and the key technology points of this foundation step. First, fabricate the steel bar installation jig required for steel bar installation. Carefully check the positions of the steel bars on the jig according to the construction drawings, and rationally and scientifically formulate the banding sequence, generally from top to bottom and from inside to outside. When installing the corrugated duct joints, use concreted ducts of the same type, but one size larger in specification, and tightly band them with a wide adhesive tape to prevent ground leakage at the joint. Ensure that the corrugated ducts are connected straight without any curvature and take good fixing measures to prevent rotation and displacement during pouring. The welded or tight rebar joints should be placed in areas with lower internal forces and arranged staged. For tight joints, the joint distance should not be less than 1.3 times to the lapsed length. For welded joints, within the joint length section, a single rebar should not more than one joint. The rebar's joint cross-section area should not exceed 50% of the total cross-section area in the tension zone, and there are no restrictions in the compression zone. For tight joints, the cross-section area should not exceed 25% in the tension zone and 50% in the compression zone. Formwork fabrication and installation. Okay, we have finished the core steel structure installation and now move on to the second key link that directly affects the appearance, size accuracy, and pouring quality of the precast box girder, formwork fabrication and installation. The formwork is like the mold of the box girder. A well-made and firmly installed formwork can avoid common problems such as concrete leakage, mold expansion, and inner mold floating during pouring. A poor one will lead to unqualified appearance, irregular size, and even rework, especially for precast box girder. The requirements for formwork modularity and disassembly and assembly convenience are higher. Next, we will focus on the material selection, installation steps, and anti-floating measures of the inner and outer formwork. These are the critical skills to solve on-site concrete pain points. Modular steel molds are used for the outer form, and all processing is concentrated in the factory. The end mold should be the same as the end of the box girder. The internal molds are used to disassemble steel plate forms, and the bottom plates are made with a notch for easy assembly and disassembly. After the bottom plate concrete is poured, and the bottom piece should be installed, followed by pouring the white concrete. To prevent the inner mold from floating during pouring, a 16 mm steel beam should be installed every 2 meters, and the pouring should be embedded in the concrete set with both ends of the lifting bar connected to the pouring for flexion. Concrete pouring. After the rebar, corrugated tile and formwork are all installed and inspected to be qualified. We enter the most critical on-site construction step, concrete pouring. This step is the process where the precast box girder takes shape, and every details from pouring sequence to vibration and operation will affect the compactness, uniformity, and Surface quality of the concrete. Many on-site quality problems such as honeycombs, pitting, holing, and segregation all occur in this link. Moreover, the pouring of box girder has strict requirements for symmetry and layering because of its special holey structure. Next, we will explain the standard pouring principles, detailed operating steps, and 7 mandatory on-site precautions. These are the golden rules to ensure the concrete quality of precast box girder. The pouring process should follow the principle of horizontal layer, vertical cementation, pouring in the sequence of the bottom plate, web, and the top plate strictly. The pouring process is as follows. Once the bottom plate concrete reaches about 6 meters, its compaction should be tested by a designed person. If the compaction does not meet the standard, vibration should be carried out inside the core mold. The pouring on both sides of the web should follow a symmetrical approach in terms of material feeding and vibration. Pouring should be done in 3 layers, and the hopper should be controlled by specialized personnel, moving slowly and ensuring that the pouring thickness is 3 centimeter. A pouring segment should be 1.5 to 2 meters long. When the continuous pouring exceeds 1 meters, a typical tap 30 vibrator should be used. Inserted vertical at 30 centimeter involves ensuring that quick insertion, slow withdrawal is maintained and the concrete reaches the bottom of the corrugated pipe and is impacted. 1. The surface of the formwork and platform should be uniformly coated with a release agent, but care should be taken not to contaminate the steel standards or other rebar. 2. The pouring process should start at the end of the box girder and gradually process to the other end. These measures in place to prevent segregation of the concrete. 3. The pouring process should proceed symmetrically to prevent the displacement or floating of the internal mold. 4. When using vibrators, the distance should not exceed 1.5 times with the vibrator's effective radius, and the vibrators should maintain a 5 to 10 centimeter distance from the set template, inserting into the concrete 5 to 10 centimeter below the surface. 5. The surface of the box girder should be roughed transversely to facilitate the bond between the deck concrete and the beam. 6. During pouring, designated personnel should monitor the stability of the formwork, rebar, and the unbanded parts, addressing any movement, deformation, or assignment immediately. 7. The arch formwork should only be removed once the concrete reaches a strength of 2.5 MPa or higher. Pre-strengthening construction. After the concrete pouring is completed and the formwork is removed, the precast box girder has a preliminary shape, but to make it meet the design bearing capacity and durability requirements for brick use, we need to carry out the core process that distinguishes pre-stressed box girder from ordinary concrete girders. Pre-stressing construction. This step is the soul of the precast box girder, which can effectively improve the crack resistance and bearing capacity of the beam body, and is especially important for large-span bridge projects. Bridge strength construction is divided into two key parts: tensioning and intelligent guarantee, both of which require high precision and standard operation. Let's take a closer look at the technical requirements and on-site operation points of these two steps. Tensioning. Tensioning can be performed using an intelligent control system once the beam body has reached design strength and the curing period exceeds 10 days. Before tensioning, adequate equipment such as limited plates, computers, and sunsheets should be prepared, and also thorough inspection should be conducted according to the system checklist. The construction personnel should receive detailed instruction on how to use the equipment. After the installation of tensioning system, the sequence and components should be checked for any issues, and the theoretical allegation values should be accurately calculated before proceeding with the tensioning operation. Intelligent granting. The granting pipeline should be placed close to the granting vehicle, ensuring that the granting and the return paths are as short as possible. The optimal distance between the concrete panel and the granting vehicle is 5 to 50 meters. Above, we have gone through the four core technical links for precast box girder construction one by one, from the foundation, rebar banding, and core bracketed pipe installation, to the formwork fabrication and installation that guarantees the shape and size, to the concrete pouring that determines the concrete quality, and finally to the pre-stressing construction that is the soul of the structure performance. These four links are not isolated. They are closely connected to the mutually restrictive. Each step needs to be strictly inspected and accepted before entering the next one, which is the core of ensuring the overall quality of the precast box girder. If you have unique insights or experiences regarding these key technologies, feel free to share with us.